Welcome to this explainer. Okay, if you're a focused learner gearing up for your engineering career or tackling the FE exam, you are in exactly the right place. Today, we're taking a highly structured approach to mastering 5 core FE exam safety concepts. And look, before we even touch a single formula, I really want to bust a massive myth right out of the gate. People think engineering safety means completely eliminating every possible danger. Well, in the real world, that is literally impossible. Instead, true engineering safety is a calculated, systematic process. So let's break down exactly what that process looks like.
Okay, let's dive into this. Here is our roadmap for today. We'll be hitting 5 key concepts. Number 1, the true meaning of safety. 2, hazard versus risk. 3, the math of danger. 4, the prevention process. And 5, important safety organizations. All right, moving right along to Section 1, the true meaning of safety, or the illusion of perfect safety. So like we just said, in the real world of engineering, eliminating absolutely every threat is just a fantasy. True safety actually means controlling known threats to achieve an acceptable level of risk. Now notice what word is completely missing there: elimination. Safety is all about active risk management. We identify hazards, we evaluate the risks they pose, and then we introduce controls to bring that risk down to a level that society and building codes deem acceptable. This is a massive, absolutely crucial distinction to remember for your exam. Safety is management, not absolute elimination. Which brings us to Section 2, hazard versus risk. This is honestly the most important concept on the exam. So the crucial point here is that in everyday, casual conversation, people throw these two words around interchangeably. But in engineering, doing that could cost you serious points on the test, and honestly, it could cost you dearly in your career. A hazard is the inherent capacity to cause harm. It's a physical quality of an object or material that just exists. Risk, on the other hand, is the chance or the probability that harm will actually occur. Hazard is that unchangeable ability to hurt you, while risk is the variable probability that it actually will. Make sense? Let's ground these abstract definitions a bit. Think about an unshielded, rotating saw blade. It has the inherent physical ability to cut human tissue, right? Or an uncontrolled high-pressure water jet. That can cause severe physical trauma. Toxic chemicals can poison you. Pathogens can cause serious disease. These things don't even need a person nearby to be hazards. Their capacity to cause harm is literally baked right into their physical nature. All right, time for a quick concept check. I want you to imagine that unshielded rotating saw blade we just talked about. If you go ahead and install a super effective, heavy-duty physical guard around that spinning blade, has the hazard completely disappeared? Think about those definitions we just covered. I'll give you a second to lock in your answer. Got it? Well, the answer is absolutely not. The hazard remains completely intact, but the risk has decreased. Seriously, do not fall for this classic test trap. A lot of people think a safety control automatically eliminates the underlying hazard. It doesn't. That blade, it's still spinning. It still has the exact same capacity to cut tissue. The hazard is unchanged. But because you put a guard over it, the probability of a worker actually touching it has absolutely plummeted. Therefore, the risk has plummeted. A safety control reduces risk without eliminating the underlying hazard. Let's move into Section 3, the math of danger, where we'll look at calculating probability and exposure. Okay, so let's translate that saw blade scenario into the actual formulas you're going to see in the FE handbook. Risk equals hazard multiplied by probability. Think of this like a simple math equation where the hazard is just a constant integer. The saw blade's inherent danger level doesn't change. But the probability? That's a variable you can control. By installing that guard, you lower the probability multiplier, and obviously when you multiply a constant hazard by a much lower probability, your total risk drops significantly. It's really just an elegant way to mathematically prove why engineering controls actually work in the real world. Now, contrast this with a slightly different scenario. Let's say we're dealing with disease-causing agents, toxic chemicals, or environmental contaminants. For these specific situations, the FE handbook swaps out the word probability for exposure. So risk equals hazard multiplied by exposure. The toxicity of a chemical is your constant hazard. The amount that actually contacts a worker's body or enters their lungs is the exposure. As exposure goes up, the risk of occupational illness goes up. It's a subtle swap, but definitely keep that distinction in mind for the test. All right, Section 4, the prevention process, the 3 steps to safety. This right here is the practical, traditional approach that professional engineers use every single day to stop accidents and occupational illnesses before they ever even have a chance to happen. You really want to lock this loop into your long-term memory. Recognize, evaluate, control. First, recognize the hazard. You have to figure out what on the job site actually has the capacity to cause harm. Second, evaluate the hazard. Look at the nature and the seriousness of it so you can calculate the risk. And third, control the hazard. You introduce guards, barriers, or policies to bring that risk down to an acceptable level. Recognize, evaluate, control.
And finally, Section 5, Important Safety Organizations. Let's decode the alphabet soup.
Let's move to this and see how it all builds out. Now, look, the FE Handbook has a massive list of acronyms for regulatory and testing agencies, but let me reassure you right now, there is no way you need to memorize every single abbreviation in that book. Don't even try. Your goal is simply to understand the general roles of the heavy hitters so you can navigate the handbook quickly. OSHA. That's your go-to directly for general workplace safety. For NFPA, the F stands for fire, so link them straight to fire protection and fire safety standards. Then you've got MSHA. The M is for mine, so they govern mine safety. The EPA is obviously the Environmental Protection Agency, focused on environmental protection. And finally, ANSI. They are the American National Standards Institute, so they handle, yep, you guessed it, standards. Grouping these acronyms logically by their core focus is a real game changer. It's going to prevent study fatigue and save you massive amounts of time on exam day. As we wrap up this explainer, I want to leave you with a final, slightly provocative thought. In your engineering career, are you just going to spot hazards, or will you truly control the risk? Remember, a hazard is just an inherent physical capacity for harm. Literally anybody can point at a spinning blade and say, hey, that's dangerous. But it takes an engineer to calculate the probability, design an effective control, and proactively manage that risk down to an acceptable level. Keep that exact mindset for the FE exam, and honestly, keep it for your entire career. Thanks so much for joining me on this explainer, and keep learning.